as we say that, my dear student, the component weight acting along the inclined plane must be equals to the mg, because it is the same with the vertical. It is the same with the vertical component after resolving. So it can be represented as the mg sine theta. So this component provide the torque on the object about the axis AB. This axis, this component, it means the component of mg sine theta could provide the torque on the object about the axis AB. Kwa hiyo hapa itatupatia ni torque. Kwa hiyo itatupatia formula ya kuweza kupata torque. Instead of finding torque in terms of Fr, it means the force acting up and the perpendicular, the product of the force acting on the perpendicular axis. We get by taking mg sin theta, then times the R is equal to torque. This we can say that torque must be equal to force times the perpendicular distance, but the force is equal to the component forces that act on the horizontal plane, as we tried to see. Therefore, instead of writing this force, instead of writing force here times R, we could substitute equals to mg sin theta times R, which is equal to torque. Now, also we tried to see that sometimes we get the torque by taking the moment of inertia we times by the angular accelerations. So here we can conclude by saying that the mg sin theta times the R represent the torque which is equal to the moment of inertia along to the axis AB times the angular acceleration. But we know that the angular acceleration is equal to the linear acceleration we divide by R. Now, instead of writing this angular acceleration here, we were supposed to substitute their formula, which is equal to the linear acceleration divided by the radius, as we see here. So this will be the equation number 88 for our fourth topic here. So we can say that we get the torque by taking mg sin theta times R, or by taking the moment of inertia along to the line of the inclined plane AB times the angular acceleration. Then we times or you can get by taking that a moment of inertia along AB, we times by the linear acceleration divided by R, where R is the radius of the rigid body. Here R represents the radius of that rigid body, as we tried to see. But IAB, the moment of inertia respect to AB, this it can be called as the moment of inertia about the axis of AB. Kwa hiyo itakuwa ni moment of inertia about the axis of AB, as we try to see. But this alpha here could stand instead of the angular acceleration of that rigid body. Kwa hiyo atakuwa ni sawa na angular acceleration of the rigid body, while A here representing the linear acceleration, my dear students. So from our equation here, from our equation number 88 for our fourth topic here, the linear acceleration of the rigid body with the axis AB can be expressed as this one. By considering the equation number 88 for our first topic here, we could obtain the linear acceleration as it is expressed like this one. Now we are supposed to take this moment of inertia along AB. Now we along AB we divide the moment of inertia along AB then we times it by the linear acceleration of r must be equal to mrg sine theta. Now here we were supposed to make r as a as the subject. The relationship that can give us the linear acceleration, my dear student, is by taking this mg sin theta times r equals to the moment of inertia along AB, we times it by the linear acceleration, then we divide it by r. Kwa hii relation na hii ndio itatupatia the linear acceleration which is equal to mr square g sin theta, then we divide it by the moment of inertia about the axis AB, as we try to see. Now we can conclude by saying that linear acceleration must be equal to mr square times g times sin theta, then we divide it by the moment of inertia about the axis of rotation AB, as we try to see here. So using the parallel axis theorem equation, we can relate the moment of inertia about this one. So now let us recall for the moment of inertia. No, for the parallel axis for the parallel axis theorem, which is said that the moment of inertia at any point must be equal to the to the sum of the moment of inertia through the center we add by the product of the square distance we times by the mass of that rigid body. Therefore, we could use the parallel axis so as to try to demonstrate at the moment, the linear acceleration as we see here. So, substituting this into here, let us take moment of inertia along AB equals to the moment of inertia along to the center. We add it by mr square. Let us take this value and substitute here so as to demonstrate the formula of the acceleration related with the moment of inertia toward the center. So if we substitute, instead of writing moment of inertia AB, we could substitute equals to the moment of inertia along to the g, then we add by mass of the rigid body times the square distance of the rigid body. But the key point you are supposed to keep on your mind is that, my dear students, this is that we have we tried to recall the parallel axis theory that give us this relation here. So this can further be simplified. Kwa hiyo ndio formula ambayo tutakuwa tunaitumia kuweza kutafuta yule acceleration. It means mr square g sin theta divided by the moment of inertia through the center, we add by the product of the mass of the rigid body times the square distance. This could be the formula that we can use so as to identify the moment of the acceleration on the linear acceleration on the inclined plane. So furthermore, you can simplify this formula. We are supposed to simplify formula by factoring out this mr square. If you factor out this mr square, the remaining formula will be acceleration, linear acceleration equals to the g times sin theta. We divide it by 1, then we add it by the moment of inertia through the center, we divide it by mr square. This will be our formula of our simplified formula for obtaining the moment of the acceleration. Finally, we can express this in a more compact form by definition of dimensionless. So we could express it in a more concept of dimensionless constant. We can say that this moment of inertia along to the center divided by mr square could be equals to the c. Kwa hiyo hapa itakuwa ni sawa na c. Kwa hiyo instead of writing ig divided by mr square, we are supposed to substitute the c, which represent the dimensionless. And this here will be our 90th equation for our fourth topic. And we know that where c here represent this moment of inertia, c is equal to moment of inertia divided by mr square. is a dimensionless coefficient. Kwa hiyo hapa jina lake tutaita ni dimensionless constant as we try to see. But the other terms that are found through our formula, I could be equals to the moment of inertia, while the M will be is the mass of the rigid body, and the R could represent the radius of the rigid body. So by saying that this will be the end of our session for our today discussion here. Now I would like to invite you again for another session. I wish you all the best. Have a nice moment.